Good morning, class. You need to take out your own paper for notes today. Preferably, if you have some lined paper, it would be best. Your learning target for today is to distinguish between arithmetic and geometric sequences, then write an explicit formula for them. Okay, so I want you to label your paper. I want to put the date on it, which is December the 11th. You're going to put arithmetic and geometric sequences on the label also. And you're going to write your learning target, and then after the learning target, we're going to do the warm-up. So your learning target again is right here. It's to distinguish between arithmetic and geometric sequences, then write an explicit formula for them. Okay, our warm-up, I've given you 4 problems. I'm going to ask you to identify the next 3 terms. So on number 1, we see 2, 4, 6. Okay, so I can tell I'm adding 2 each time. So my next 3 terms here would be 8, 10, and then 12. If I look at the second problem, I have A, C, and E. So I notice I'm skipping a letter in between each value. Each one I'm skipping a letter. So my next terms will be G, I, and K. The next one, I have -9, -6, and -3. I can tell I'm adding 3 each time. So my next 3 terms would be 0, 3, and 6. Okay, number 4, I have A, E, and I. It's really tempted to say O and U, sometimes Y, the whole vocab thing, but not, I need to think what is going on between A and E. What's going on between E and I? Well, I know between E, I have B, C, and D. Between E, I have F, G, and H. So I'm skipping 3 letters. So my sequence would look like M, Q, and U, because I'm skipping 3 letters between each term. Alright, the vocabulary we need to learn for today's lesson is sequence, and that is a set or list of numbers that are in specific order. Term, in parentheses, and it's each individual value in a sequence. A sub n is a specific term that you're trying to find, and then A sub 1 is the first term in a sequence. Okay, we're going to talk about arithmetic sequences first. Arithmetic sequences are very similar to linear functions. You are going to be looking for the values to have a constant rate of change. That means the same rate of change, and this change is called the common difference, and we call that, we express it by the letter D. And here's the formula. A sub n is equal to A sub 1 plus n minus 1 times D. So this is the specific term we're looking for, is equal to our first term plus the n of the term we're looking to subtract 1 times our common difference. Okay, so let's look at the first example. The first thing we want to do is to define our terms. So 32 is my first term, -2 is my second term, 28 is my third term, and 58 is my fourth term. Then I want to define my common difference. What's happening from -32 to -2? What's going on from -2 to -28? Okay, well, if I can tell that I am adding 30 each time. So once I have defined my terms and established my common difference, I can write the equation. Remember, the formula for the equation is A sub n equals A1 plus n minus 1 times D. So I substitute the values I know. A sub n is equal to -32, it's my first term in the sequence, plus n minus 1 times my difference. I distribute the 30 to the parentheses, 30n minus 30, combine my like terms, and I get 30n minus 62 is my explicit formula for this sequence. Okay, now I want to find a specific term. Let's say I want to find the 10th term in this sequence. Well, I can go ahead and add 30 to each term till I get to the 10th term, and I get that it's 238. Or I could use the formula. And I know the formula was A sub n equals 30n minus 62. I substitute 10 in for n. I get the math. I get A sub 10 equals 300 minus 62, and I get A sub 10 equals 238. It's the same number I got if I just added the 30 each time. Let's look at our second example. We define our terms. A sub 1 is 8.1 is my first, 5.8 is my second, 3.5 is my third, and 1.2 is my fourth. Then I'm going to find my difference. What is happening between 5.8 and 8.1? 5.8 and 3.5, 3.5 and 1.2. Well, if I notice the difference, I know I'm going down, So I'm subtracting 2.3 each time. Okay, so now I know my terms, I know my common difference, I can write the equation. A sub n is going to be equal to 8.1, which is my first term in the sequence, plus n minus 1 times my common difference. Distribute the negative 2.3, combine my like terms, and I get a sub n is equal to negative 2.3n plus 10.4. Okay, now let's find the 23rd term. Well, I am not going to want to sit here and subtract negative 2.3 till I get to the 23rd term, so I'm going to use the formula. A sub n is equal to negative 2.3n plus 10.4. I'm going to substitute 23 in. I'm going to do the math, and I get a sub 23 is equal to negative 52.9 plus 10.4, and I get a sub 23 is negative 42.5. Okay, let's look at geometric sequences. Geometric sequences are very similar to exponential functions. We're going to be looking for values to have a rate of change, just not constant, which is called the common ratio, and is expressed by an r. My formula here is a sub n is equal to a1 times r to the n minus 1. It's going to be an exponential problem here. So a sub n is the specific term we're looking for. A sub 1 is the first term in the sequence. Okay, so let's do an example. So first thing I do is define my terms, as we did with the arithmetic, and now I'm going to find my common ratio. So common ratio, I'm going to look at what happened between 0.3 and 1.5, 0.06 and 0.3, 0.012 and 0.6. Well, if I look at that, I realize that I am multiplying by 0.2. I would find that, I can tell right away that they're not adding the same amount, so it's not arithmetic. So I want to divide 0.3 by 1.5, 0.06 by 0.3, and so on. 0.02, you take the second term, divide it by the first, the third term, divide it by the second, the fourth term, divide it by the third, and so on, to get your common ratio. Now you're going to write the equation. A sub n is equal to a1 times your ratio to the n minus 1. So this is going to be equal to a sub n times 1.5 times 0.2 to the n minus 1. So this is my explicit formula for this problem. Okay, now I'm going to find a sub 8. Again, I could go through and I could multiply by 0.2 and find the 8th term, but it's a lot easier if we just substitute in 8 for my n, and I did that, and I have 1.5 times 0.2 to the 7, because 8 minus 1 is 7. Do the math, and I wind up with a sub 8 is 0.0000192. Okay, example 3, I have fractions. Same thing, you're going to define your terms, 2/5, 8/15, 32/45, and 1/28 over 135. Now I'm going to define our common ratio. What is going on between 1 and 2, 2 and 3, and 3 and 4? Well, if I do the math, I see that from 2 to 8, I multiply by 4, and 5 by 15, I multiply by 3. 8 to 32, I can multiply by 4. 15 to 45, I'm multiplying by 3. So I know I'm multiplying by 4/3. That will be my common ratio. That is my r value. So I'm going to multiply it, put it into the equation. A sub n is equal to a1 times r to the n minus 1, and I get 2/5 times r 4/3 to the n minus 1. So now you're going to get some practice on your own. For each problem, you're going to determine if the sequence is arithmetic, geometric, or neither. Then you're going to write the formula. Then find the nth term. You'll be given a term to find. What you do not finish in class must be done for homework. See ya on Monday.